This is a brief introduction of how to use these forms to be able to help you determine the formulas for different ionic compounds. Note, by the way, this is for ionic compounds only. This does not work for covalent compounds. So the ionic compound we will look at first is sodium oxide. First, before you even start messing with the pieces, we have to know what things to use. You'll notice we have this in two words, and this is going to break into two halves. The first word is always going to be the cation, which means it is positively charged. The second word will always be the anion, which is going to be the negatively charged ion. So now we just have to figure out what the formula and charges are, and then we can start messing with these pieces around here to figure out the overall formula. So since we're dealing with sodium, you look on the periodic table, and sodium's formula is Na. From that formula, you can also tell from the periodic table that the number of valence electrons it has is 1. When sodium becomes an ion, it is going to lose that 1 electron and become a positively 1 charged cation. Oxygen, the formula for it is O, and it has 6 valence electrons. And when it becomes an ion, it is going to gain 2 electrons. So I would have a Lewis dot structure that looks like this. And it has now 8 valence electrons and a charge of -2. All right, so the pieces that I'll be able to use for the cation portion of this are the +1 pieces. So out of these 3 stacks on the side, because sodium has a +1 charge, I'm going to use these pieces here. So now, these other sets I cannot use for this particular problem. I can only use the +1s. Same is going to be true for the negative portion, or the anion portion. The oxide anion, has a -2 charge. So these are the ones I get to use, and the -1 and -3s would have to be saved for a different problem. So now what I'm going to do, so here's my -2 charge. Now I need to figure out how many of each of these do I need to make this neutral. So if I just have 1 of each, you'll notice that doesn't quite line up yet. All right, so then what do I have to do? Well, I need a second +1 ion. So now you'll notice that these match up top and bottom. All right, so that means I am going to be using 2 NAs and 1 oxygen. So here is ultimately, once again, a recap of what I did. Step 1, I looked at the name, separated out the name into 2 parts. There's the cation portion and the anion portion. The cation portion for this is sodium that has 1 valence electrons, and it's going to lose that 1 valence electron to have a +1 charge. So the pieces that I can use to build my model are going to be the +1 ions, and specifically the +1 cations. The anion portion, or the second half, is oxygen. It has 6 valence electrons as an atom. It's going to gain 2 electrons, and when it does, it will have a -2 charge, which means I'm going to be using the -2 pieces. And then at that point, I just have to try to line up as many as it takes from each one. So you'll notice I used 2 of the +1 ions and 1 of the -2 ion to be able to make this stack up and be even. So the formula for the sodium oxide is Na2O.